we're going to be focusing on getting our Tensorboard with our logit output. I think we can do it. We can see how much loss that we are achieving. I believe we succeeded at rendering our model yesterday successfully by setting up all of our layers. We've got 4 conv layers, a pool, and 3 linear layers on the output with the number of classes that we're targeting. Since we're using animals as our input data, we are going to have a bunch of labels that are pre-written for us. We've got, what is it, like 36 labels? I think it's 36. We counted it yesterday. Yeah, there are 36 classes. And so that's going to give us the output targets for our class, and we know what the labels are. This, I believe, is everything we need to get going. I think it is. I think we're going to have a good time with this. So let's get going here. So I also believe that we can increase the batch size. I want to try that really quick. All right, get status. Okay. Let's see, was it RM? RM, here we go. Let's run that Tensorboard command. All right. So this is as is, good to go. Although the output size, is that correct? Is that what we're looking for? This feels incorrect to me. Our output size should be something different. It should be our classes. Do we actually do that? We did right here. L3 output right there. That's what we did right there. Hey, Dreamer, welcome on in. Yeah, you're number 1. Good to have you here. You made it in. Welcome on in. All right. So let's see here really quick. Here's what we'll do. All right, perfect. So I think, does everything look good here? Yeah, okay. I think it all looks proper and correct. L1, L2, and L3. Oh, that's why. I was like, why did that not look right? Well, it turns out because it really wasn't. Okay, perfect. There we go. That's what I'm looking for. Excellent. Okay. Right here. Check that out. 36 classes. Perfect. One batch. Batch of 1. That's what we're looking for. Like, why isn't that working? It's because it was broken. Okay. So we've got our input data. We got our output data. We got our classes that we just fixed just now, this very moment, which looks a lot better, by the way. Oh, it looks so much better. Where are we printing? Oh, we're printing the output here. Okay. So those are our logits. This is our class probability right here. Thank you for the likes, you guys. Appreciate it. All right. So this is the probability that it's going to be one of a type of animal. I think it's going to be animal breed, right? You've got cats and dogs. We've got our Tensorboard here. And if we look through it, we've got a whole bunch of different types of animals. Although, I need to rerun that here. Let me reload this. Why is it only 2? Hey, Kyle, good to see you. So that's a batch of 1. Let me see if we can do bigger batches. Let's see if we can do more batches. Let's try this. This is something that we got to test out. If it doesn't work, it doesn't work, right? So let's do 4x4. Let's rerun that. Close our Tensorboard and restart it. Looks good to me. Yep, there we go. That's the kind of thing I want to see. Oh, that looks so good. I love it. I love it. Let's see. You were also the one distracting you with the like buttons. Oh, Deshifer? Wait, how do we say your name here? Is it Deshifer? Am I saying it right? Better and better, Dan. Okay, so now that we've got this, all right, let's do the batches work too. All right, the batches work great. If we reload this, we should see a batch size. There we go. Perfect. Now we've got all of our input data that we can stream over to our GPU and it will be highly accelerated. Excellent. Actually, let's see if we can go even bigger. Let's do a little bit bigger. So we said batch size of, let's go 8. Let's do 8 size here. Let's see if that works out. Restart Tensorboard because it seems like you need to do that. Yep, there it is. 8. We got 8 size right there. I want to do some loss. I think we have to do negative log likelihood loss for this style of classes because we did not one-hot our outputs. So we need to have a loss definition. Where's that at? Where's our model defined at? Here it is here. Okay. So we're going to need our criterion to be a torch.nn.nlloss. Right? Negative log likelihood of loss. Criterion. What is... I need to look this up really quick. Plus y. I need to look this up really quick. Where is this? I think I can click on this and it'll just show up here. So this is going to be our... Let's see here. Where do we do this? References. Torch in. All right. In LLLOSS. LOSS. Perfect, right here. The negative log likelihood loss is what we want to do. It provides the optional arguments of weights. We don't need that. We just need the log. Okay, we don't need to put any special params. Weight size average, reduce none, ignore index. Okay, so we're not gonna have any indexing ignoring. I think this should be fine. Though I am curious to see what it wants here. Oh, it's using cross entropy loss. Well, I know cross entropy loss works a lot better if we use our carve. Okay, Corv 1249. So we are building a convolutional neural network, and we're going to train it on animal data. We've got some animal data here. So we got some pictures of animals. It's kind of hard to see there. I have to zoom in a little bit. What I could do is I need to reduce the batch size there real quick, so it's a little bit easier to see. We'll do a batch size of 2, and we will update the epochs. Epochs, here we go. Epochs. Wait, I didn't find it. Epoch. Here we go. It is there. What do you mean? Oh, range. Okay, right here. Wait, here we do. Epochs equals, we'll do 30 epochs. So that way we know what's going on there. Well, instead of I think we'll call this epoch. So we know what's going on. Make it a little bit more obvious what that is. Let's see here. Okay. Oops. All right, did I close that? I did, okay. Does that all work? Yes, I did. I saved it. All right. So we should be able to rerun this. And I believe that's our criterion. We're going to try negative likelihood loss log first. Here we go. So you see we've got some pictures of animals here. We've got some dogs and cats and dogs. Batch sizes here. Batch size of 2. Next time it's a band. Oh yeah, no tolerance for that. Thank you, Kyle. Appreciate it. There are some cameo or microwave turn off reminder from a positive pal. Well, Dreamer, appreciate it. I mean, that sounds really positive what you're saying there. I don't know what it is specifically. Sometimes I can't understand. Okay, let's keep going. All right, so this is our input data training here. I want to calculate the loss really quick. Let's see if we can do that. All right, loss equals the criterion, the out, comma, the label. I think that's it, right? Since this is going to be labels and images, labels, because it's a batch now. Epoch labels. Okay, perfect. Okay. Nice. All right, let's see if this works. Before I do that, I'm going to rerun this to make sure everything... Let's try using our criterion and print out the loss. Print loss. See what we get. I think we should be able to get a good loss here. And then we'll backpropagate and do some training. Okay. So I think that should be sufficient. I'm just going to say loss like this so I understand what that looks like here. All right, it might not work. It might crash. Yeah, okay. 36 is out of bounds because we might need to initialize it. Also, it might not like batches. And we might have to reshape our loss output. We might have to reshape it. Still with those creepy images of dogs. Yeah, well, we can make them not creepy. Here you go. All right, there. That will make them non-creepy. There we go. Wait, oh, well, let me see here for NLL. Let me turn this off really quick. The criterion. Let's hide that. Redo. Okay, so now we should be able to reload this. And we will see much better colors. Yeah, there you go. A little bit nicer, right? Just a smidge nicer. We did have to normalize, reshape them so that way the image sizes are in the right spot. You're stuck with auto? What does that mean? What do you mean stuck with auto? Oh, right. Okay, right. You are stuck with auto, which in cursor, it will pre-select whatever model it chooses. Got it. Understood. Auto model router. Yes. It'll pick the one that it decides. So I need to see here in index error 36 out is out of bounds. Do we need to specify something? Here. I believe we should be able to find it. Right. Grep. We'll do this grep in LLL star. that is going to, no, we don't. We don't. I don't think so. Yeah, it's just like that. So why is it out of bounds? Do we need to reshape it? Is it only batch size of 1? What if we just did cross entropy instead? Let's just do a cross entropy. And we'll deal with lower learning rates. All right, so this will be torch.nn.cross entropy. What was that called? Cross entropy something? Here, let's go back to the docs here real quick. Where's that at here? Where did we have that? Was it here? Yes, okay. Here, oh, cross entropy loss. Oh, I mean, come on. LOSS, there you go. Anything that we have to specify with cross entropy loss. And then we're gonna need an optimizer. Optimizer equals optim. Did we already specify that? Yeah, we did, okay. Dot atom w parameters equals model dot parameters. And LR equals 0.001. I believe at the right spot. So I'm gonna go to cross entropy. I think this will work with batches. So we should be able to succeed this time, right? Oh, I need to define model up higher. There we go. Classes and epochs should be up a little bit higher as well. So we got our hyperparameters, we got our model, we got our training data, we've got a writer for Tensorboard. How's it going there, Matthew? Thank you for saying hello. Good to have you here. Happy Wednesday. We are building a convolutional neural network, and we are going to try to figure out how to add with the writer, which is Tensorboard, add our loss output to Tensorboard directly. Got an parameter. Isn't that? Oh, did I do that wrong? Parameters? Do we just specify it like that instead? All right. 36 is still out of bounds. What am I doing wrong? Let's see here. Let me go to our code really quick. I'm pretty sure I'm doing this properly. All right, so that was called cross entropy. Yeah, this is perfect. All right, so we did it properly. All right, got our parameters. We don't need to worry about that. We're using atom W, so it's no different. And then, oh, I might be doing that in reverse. Outputs labels. No, I'm doing it properly. 36 is correct. Target 36 is out of bounds. Oh, maybe it's 37. Maybe. Let's try that. That's what it was. That's what it was the whole time. All right. We're gonna use negative log likelihood. Let's try that. Okay. Nice. Oh, there it goes. Okay, now we're on the right track now. We're on the right track. That item. So we get that a little bit prettier on the screen. Okay. This is great. This is great. The top 50 had 1,250 EXP. Wow. Loons. That is much. Hey, Tony, good to see you. Tony Soprano, welcome on in. Good to have you here. I didn't see your message there because you got moderated. Thank you, Kyle. Appreciate it. All right, so if that's our loss is also already very low. It's very low. I have no idea how it's that low already. That's amazing. Maybe because the batch size is really small. We should increase the batch size, maybe. Yeah, let's increase the batch size. Just a smidgen. Then our loss should increase. Is it bigger? Yeah. Let's bring it up to 20 and like really set it. I want to see a very large loss. Nope. Okay. Let's just do a batch size of 2, and then we'll run this over a few. And this is an epoch though. We're currently building a convolutional neural network, which is a network that's going to give us the ability to determine output that has proximity. So it's images, basically. We're training on images. And where's that at here? Okay. So we've got a little example here. Where we got that at here? Is this going to show? Yeah, here we go. So basically, we've got this picture here with a cat, right? We've got a picture with the cat. Let's just say this is a cat here. And we've got all these pixels, right? You see these pixels on the screen? Each of these pixels. What we want to do is we want to capture information and collapse and pool on nearby pixels. So pixels over 2 dimensions. That's what a convolutional neural network is for. It is able to, on a ConvNet, it can take samples of outputs across each of these related pixels and find some sort of meaning. It can pool them. You can either average them together. You could find the max, like which one of these pixels has the brightest, basically, which one's the brightest. And that's what we're doing. We're looking for the brightest pixels when we're scanning over a stride of 2. So it does this. It looks like that. It'll do 4 samples, essentially, in this particular representation of the image. Now, our image sizes are very big. They're 200 by 200. And you can see an example right here. That's cool. Via a kernel. You got it. We got distracted yesterday. Neva, we got pretty distracted yesterday. And so we didn't really do a whole lot. Today, though, we got our model working, and we're going to try to train it to make sure it's got lost, and then we're going to print it in Tensorboard. Just to see, we're going to try it out. I always like to just use the terminal. I don't really want to jump out of the terminal and go somewhere else. So this isn't something that I necessarily plan on using in my normal endeavors with AI. However, Tensorboard, it's pretty neat. They're going to do something here. It's actually pretty nice, especially if you're trying to take a look at some of these things. I think it's pretty neat. Do reload. Oh, wait. How big did I put my batch size at? This is a little bit big there. I didn't mean to make the batch size that large.